In this problem, we're told one 110 kilogram football lineman is running to the right at 2.75 meters per second, while another 125 kilogram lineman is running directly toward him at 2.6 meters per second. What are A, the magnitude and direction of the net momentum of these two athletes, and B, their total kinetic energy? So let's draw what's going on. So imagine we have two different linemen. Here's one, and he has a mass of 110 kilograms, and his velocity, right, is going to be equal to 2.75 meters per second. So he's running this way. And so we have another one. Let's say this is our other lineman. And their mass is 125 kilograms, right? So and he's going to be running in the towards the other guy, right, to the left. So his velocity is going to be, and so keep in mind when we're saying direction, we want to label to the right positive and to the left negative. That's generally how you do it. So this guy's velocity is going to be positive, but this one we have to label negative because he's going to the left. So his is going to be minus 2.6 meters per second, right? So this is just a diagram what's going on. So let's start with each part. So A is going to be the magnitude and direction of the net momentum of these two athletes, right? So the net momentum, keep in mind what momentum is. It's mv. So P, which is momentum, equals mass times velocity. And so we're trying to find the net, right? So the net momentum, what the net momentum is going to be is just going to be their momentums added up, right? So we just want to add both their momentums. So let's go ahead and do that. So let's start with this one. So we know momentum equals mass times velocity. So the mass of this guy is 110, right? Multiplied by the velocity, which is 2.75. And then we add the other one, which is going to be 125. That's that mass, right? We're just following along this equation multiplied by his velocity. And keep in mind this one's negative because he's going the opposite direction. So times minus 2.6, right? So go ahead and do this. 110 times 2.75. This is going to be 302.5. And then 125 times minus 2.6 is minus 325, right? So the net momentum, if you want to do this, 302 minus 325, you're going to get minus 22.5. And in the units, this is kilogram, right? Momentum's measured in kilogram meters per second, right? The velocity times the mass. So minus 22.5 kilogram meters per second. So keep in mind the magnitude is just going to be 22.5, right? Because you just take the absolute value. But we specify the direction. So 22.5 kilogram meters per second. And then the direction, since it's negative, remember we specified that's to the left. So you can say 22.5 is going to be the magnitude of the momentum, and it's directed to the left. So to the left. But yeah, so 22.5 to the left, that's going to be the magnitude and direction of the net momentum. Now we want to find B. All right, let's do B now, which is the total kinetic energy. So kinetic energy, right, K, we know is equal to 1/2 mv squared, right? So what we're trying to do is just add them up, right? We're trying to find their total. So you can just say KT or K total. Let's just take the kinetic energy of each of these individuals. So let's start with the first guy right here. So 1/2 times their mass, which is 110, multiplied by their velocity squared, which is 2.75 squared. So that's that guy. And I'm going to move down a line, but same line essentially. Now let's do this one. So it's going to be 1/2 times this guy's mass, which is 125, multiplied by his of velocity squared, right? So his is minus 2.6. It's not going to make a difference though. And the reason that is because it's going to be squared, right? Which just makes it positive no matter what. But you can still label it negative. It doesn't make a difference. So minus 2.6 squared, you can make it positive or negative, whatever you want to do. It's going to be the same. So go ahead and do this. Let me plug it in my calculator. So we're just adding up the kinetic energy of this person and then this person, and it's going to give us the total. So 1/2 times 110 times 2.75 squared, right? And then you're going to add 1/2 times 125 times minus 2.6 squared. So go ahead and do this. And when you add these up, right, you're going to get 800, right? So add both these up, you're going to get 838.4375. And so what I'm going to do is just round just to the whole number. So 838. So 838, and then keep in mind kinetic energy is measured in joules. right? So 838 joules, that's going to be the total kinetic energy, right? So that's your answer to B. This is B. And then this right here was your answer to A, right? So the magnitude and the direction. But yeah, so these are going to be your answers, and hopefully you found this useful.